Do you know the breath you took just now can be analyzed by the graph of trigonometric functions? And this breathing cycle is the closest link to both life and death. In this video, we will learn new and exciting things about trigonometric functions. So do watch the video till the end. Now take a deep breath and relax. So as far as we have discussed 4 topics in trigonometric functions, if you have not seen those videos, I urge you to see those videos first and then come to this video. Links are given in description. Okay, so today we'll discuss graph of sine and cosine function. Now this video will come in 2 parts. Today in this video we'll discuss only the graph of sine and the variations of sine functions. In the next video, the coming video, we'll discuss for cosine functions. Okay, first thing first. Till now we were representing angle with the letter T or theta. But now we'll use the symbol X to represent the independent variable and or to represent the angle theta, and the symbol Y for the dependent variable. So what will be graphing? We'll graphing the function y is equals to sine x, right? Here x is the angle in radians, right? And y is the dependent variable. So let's proceed. अब ग्राफ कैसे बनाया जाए? So to plot the graph, we'll go to the basics of plotting a graph of a function. So we'll take different values of independent variable x and we'll list some points on the graph. Okay, and one more thing, since we know that the period for sine function is 2 pi, so we'll take the values from 0 to 2 pi and then we can repeat the graph, because next the values will going to repeat. So we're going to graph the function in this interval. So when x is 0, what is the value of y? Y is also 0, because sine 0 is 0. Now when x is pi by 6, then y would be 1 over 2. Then pi by 3, then y is square root 3 over 2. Then pi by 2. Now sine pi by 2 is 1. Now next we can take 2 pi by 3. Then we can take 5 pi by 6. हम जो ये values ले रहे हैं x की, that we are taking at an interval of pi by 6. So 5 pi by 6, then pi, right? So here it would be square root 3 over 2, then 1 over 2, and then 0. Next we can take 7 pi by 6, then 4 pi by 3, and then 3 pi by 2. Here you will get negative 1 over 2. Now we have entered to the third quadrant, so minus square root 3 over 2, then minus 1. Now we'll be entering into the fourth quadrant, so 5 pi by 3, then 11 pi by 6, and finally 2 pi. Here you will get minus square root 3 over 2, minus 1 over 2, and 0. So these are the values of x and these are the values of y. We can plot these points on a these points on a graph paper to obtain the required graph of the function. Okay, so if you plot the graph, it will look something like that. This is the y-axis we will be taking, and this is the x-axis, right? Now here we have 0, then pi by 6, then pi by 3, then pi by 2, then 2 pi by 3, and then 5 pi by 6, and so on up to 2 pi. Now here when x is 0, y is also 0, so this is the point. Now when x is pi by 6, y is 1 over 2. So here I can take this is 1 over 2, and this is 1, and this is negative 1 over 2, and this is negative 1. So when x is pi by 6, this is 1 over 2. Then when x is pi by 3, this is square root 3 over 2, and square root 3 over 2 is approximately 0.87. So it would be something here, right? And when x is pi by 2, we reaches the y value to be 1. If we join all these points with a smooth curve, it will look something like that. Then again, you can plot all these points like that. Now if you plot the points like that, you'll get the curve like this. This is the perfect curve for the sine curve in the interval 0 to 2 pi. Right here you can see when x is 0, y is 0. When x is pi by 6, y is 1 over 2. X is pi by 3, y is square root 3 over 2, which is 0.87. Then pi by 2, it reaches at exactly 1. You can see here, right? And so on. Now after 2 pi, this curve will going to repeat. Again this will move like this, like this. Again it will move like this. So this is the sine curve. Now this is the more perfect curve for y equals to sine x. Here this curve, this was a period for sine pi, that is 2 pi. This curve is repeated to the right side and also to the left side, because the domain for the sine function x, it is from minus infinite to infinite. It can go from minus infinite to infinite, right? So the curve will go to the right side and to the left side. This is just a repetition of this curve. This curve is being repeated to the right side and also to the left side. So from this graph, what we can say, or what we can conclude, that the domain of the function is minus infinite to infinite, right? And the range is minus 1 to 1. Here you can see that the y value ranges between minus 1 to 1. And what is the period? Period here is 2 pi. This is the period. Period means after this the values will going to repeat. This is what you mean by period. So this is a period. Now the sine function is an odd function. Sine minus x is equals to minus sine x. This thing we studied earlier also, and this can also be observed from this graph, that the graph is symmetric with respect to origin. Here we can see that. So this is all those things that we can conclude from this graph. Now let's discuss the variation of the function y equals to sine x. Okay, now to graph the variation of y equals to sine x, it is helpful to find the x-intercept and the maximum and the minimum points. Now here we can observe from the sine curve that we have 3 x-intercept. This one, and this one, and 1 the maximum point and 1 the minimum point, right? So the x-intercept occurs at the beginning, middle, and at the end, and the maximum occurs at 1/4 of the period, and the minimum occurs at the 3/4 of the period. So there are basically 5 key points, right? Point number 1, point number 2, then point number 3, point number 4, 5, and this was point number 2, right? Now how to find the x coordinate of these 5 points? To find the x coordinate, divide the period by 4. Here the period is 2 pi, right? Let me generalize the things. X1 is what? The value of x, where the cycle begins. Where cycle begins. Right. Now to find the x2, add x1 with the period divided by 4. Here the period is 2 pi, so add x1 with 2 pi by 4, which is pi by 2. Right. Now to find x3, x2 plus period by 4. Same thing we're going to repeat for x4 also and then x5 also. Right. So these are the ways, this is the way we calculate the 5 points. Now to find the y coordinate, just plug these x value into the function to find the y. Now suppose we have the function y is equals to a sine x. This is the function. Now the graph of y equals to sine x, this forms the basis for graphing this function. For example, here a is 2, right? If the value of a is 2, so we have to graph y equals to 2 sine x. Correct? Now here we can obtain the graph by multiplying each coordinate on the graph y equals to sine x by 2, exactly by 2. And here we see that the sine curve will range between -2 to 2. People will say that I'm not able to understand what the hell you are saying, man. How the range is becoming from -1 2 to 2. Earlier it was -1 to 1 and so on, right? People may find it difficult, but once we'll take an example, then all our problems will be clarified. So first just try to understand what I'm saying, and then once we'll take the example, things will clear. Okay. Now here in general we can say that for the function y equals to a sine x, the y value ranges between -1 minus a to a, right? And if you see the amplitude is a. Amplitude for this function is a. Now if the value of a is greater than 1, that means that the sine curve is stretched. And if the value of a is less than 1, sine curve is shrunk. Now one question for you: what is the maximum value of y? Simple. Maximum value of y will be the amplitude, which is a here. Now we can conclude that the steps to graph the variation of y equals to sine x. First, identify the amplitude. Amplitude is what? This is the amplitude. Then find the x values at 5 key points. I've already mentioned that how to calculate the 5 key points. First, identify the period. What is the period? And then divide the period by 4 and then find the 5 key points like this. Then calculate the y value at these 5 key points. Right. Fourth step is connect all the key points. Connect all the key points. And finally, you can extend the curve in the left or the right side as per required in the question. So this is the overview to graph a function which is in this form. This is the 5 steps that you should follow. Now let's take an example, then you will have a better understanding for this kind of functions. Okay, so this is the example. Here we need to determine the amplitude for the given function, and then we have to graph the function y equals to sine x and also y equals to half sine x in the interval this much. Okay, so if you compare the given function with the standard one, y equals to a sine x, we can say that the amplitude would be 1/2, right? and then we have to graph y equals to sine x, that we have already drawn earlier. So I'm just taking it as it is. So this is the graph for y equals to sine x. Now we have to graph y equals to half sine x. So to graph this, first we have to find the 5 key points that I discussed earlier, and also we can say that the period for half sine x and sine x would be same. The period for y equals to half sine x would be 2 pi itself. I think I missed out earlier. The period for y equals to a sine x is same as the period for y equals to sine x. So period is 2 pi. So after every 2 pi angle, the curve will going to repeat. Now here the period would be 2 pi. Now to find the 5 key points, the first x1, this would be 0. x2, this would be, you have to add x1 plus period by 4. Period is 2 pi. So 2 pi by 4 is what? Pi by 2, right? So 0 plus pi by 2, 0 plus pi by 2 would be pi by 2 itself. Then x3, again add pi by 2 to this x2, you'll get pi. Then x4, this would be 3 pi by 2. And finally x5, this would be 2 pi. Now find the corresponding y values. So when x is 0, when you put x as 0 here, you'll get y to be, because sine 0 is 0, so y would also be 0. So y1 is 0. Next y2. So when you put x as pi by 2, you'll get sine pi by 2 is 1. So 1 over 2. 1 multiplied half is 1 over 2. Then for y2, y2 would be 0 again, because sine pi is 0. Then this was y3. Now y4, this would be minus 1 over 2. And finally y5 is 0 again. Now if you plot all these key points here on the graph, here x is 0, so y is also 0, x1, y1, x2, y2, pi by 2, half. So this is half, and this is negative half. So here this would be the point. Then pi and 0, so this would be the point. Then 3 pi by 2 minus half, so this would be the point. And finally this would be the point. Now join all these points with a smooth curve like this. Like this. So this curve will represent y equals to half sine x. Now what this half is representing? Half is representing the amplitude. This amplitude, the maximum up to which the curve can go. This is the amplitude A. And while defining, we always take a mode value, because the curve will go towards the negative half also, like this. But while representing or while telling the amplitude, we always take the magnitude, half. And if you say that what is the amplitude for y equals to sine x, so that would be 1. This would be the amplitude for y equals to sine x. This is 1 here, right? And what is the period? Period after which the curve will going to repeat itself. This is the period 2 pi. And for both the curve, that y equals to half sine x and y equals to sine x, the period is same. Period will not going to change depending on the magnitude. This will not going to change. We'll see in the later portion of the video that when the period will going to change. But for these kind of curves, period for sine x, because sine x is as it is, just the y value is changed, sine x is not changed. So period will remain the same, but the y value has decreased here, because this is half of sine x. So the curve is shrunk here. You can see the graph also, the curve is shrunk, that I've mentioned earlier. When a is greater than 1, then the curve will going to stretch, and if a is less than 1, the curve will going to shrunk. That you can see here also. Now let's take some more examples. So here in this example we have that the function we have y equals to negative sine x, and then we have to graph the y equals to sine x, that we have already done it, and also the graph for this. But here the interval has changed. Here the interval we have minus pi to 3 pi. Okay, now amplitude, it's pretty simple. We just take the magnitude of this coefficient, which is minus 2 here. So magnitude of minus 2 is 2. So this is the amplitude. Now the graph for y equals to sine x, this is pretty simple, that we have already drawn. So this is y equals to sine x. So I'm taking directly. This is y equals to sine x. Now then we have to graph y equals to minus sine x. Okay, minus 2 sine x, sorry. Now we have to sketch the graph between this interval, but still we'll take x1 to be 0, rather x1 to be negative pi, because we know that the graph shape on 0 to 2 pi will enable us to sketch the graph on the given interval. Simply we have to repeat the curve, right? If we are able to sketch the curve between this interval, then after that simply we have to repeat the curve to the left side or to the right side. Okay, so x1 is 0 here. Now what would be x2? How to find the second key point? Just add, here period is 2 pi, so divide period by 4, that would be pi by 2. So add pi by 2 it. 0 plus pi by 2 is pi by 2. Then x3 would be pi, x4 would be 3 pi by 2, and finally x5, this would be 2 pi. Now when x is 0, y1 would also be 0, because sine 0 is 0 multiplied with minus 2, so that is 0. Now y2, so that would be sine pi by 2 is 1, so my 1 times minus 2 is minus 2. Then y3, this would be 0, y4, this would be here, this would be plus 2, because sine 3 pi by 2 is negative 1, so negative 1 multiplied with negative 2 is 2. Then y5 is again 0. Now plot these points on the graph. That would be here. Now here it should go to minus 2. We have to go to minus 2. So suppose if I extend this line, so if I extend this line here, this is minus 2 here, and if I extend in the vertically upward direction, so this is plus 2 here. Okay, now plot the point. So when x is pi by 2, this is minus 2 here, so this is the point. Then 0, so this is the point. Then 3 pi by 2 and 0, 3 pi by 2 and 0, 2, 3 pi by 2, this is when x is 3 pi by 2, y is 2, so this would be the point, and finally 0. Now join these points with a straight with a smooth curve like this, smooth curve like this. So this curve will represent y equals to minus 2 sine x. Now here you can see that the curve is stretched, right? You can see the curve is stretched because here mode A is greater than 1. You can see mode A is 2 here, so which is greater than 1. So here, since mode A is greater than 1, so the curve is stretched here, right? So we have sketched the curve for the interval 0 to 2 pi, but we have to sketch for minus pi to 3 pi. So we have to repeat the curve in the left side and also in the right side. So this is the curve for y equals to sine x between the interval minus pi to 3 pi. Now let us sketch the curve for y equals to minus 2 sine x between the same interval. So here we have the first point, This is the second point, third point, and then this is the fourth point, and finally the fifth point. So the curve would be like this between 0 to 2 pi that we had drawn just now. Smooth curve like this. Now simply repeat this curve. Let me draw it again. Now repeat it. So after repeating, you'll get like this. Repeat this curve in the negative direction also. So this would go like this, reaches to the maximum point, and then this. So this would be the curve between this interval for this is y equals to ये वाली curve जो है, this represents the function, this one, y equals to -2 sine x. Now let's move forward. Now if the function is of the form y is equals to a sine bx. Now इस type of function को कैसे sketch करें? So we know that for y equals to a sine x, here x is between 0 to 2 pi. So for this case, bx, this should be 0 to 2 pi, right? This is the period for sine x, so this would be the period for sine bx. Now divide with b both the side, so you'll get 0 to be greater than or equals to x, less than or equals to 2 pi by b. Thus we can say that the period for this kind of graph is 2 pi by b, right? And here a is the amplitude, right? Now if b is greater than 1, then what does it mean? So if b is greater than 1, it means that the graph is horizontally shrunk. Horizontally shrunk. Why shrunk this time? Because if b is greater than 1, the period will going to decrease. If period decreases, the graph is horizontally shrunk. But if b is less than 1, so this would be horizontally stretched. The graph will be horizontally stretched, right? So I can conclude here that if the graph, you have to graph the function a equals to sine bx, where b is greater than 0, then the amplitude is mod a and the period is 2 pi by b. Let me represent on the graph. So this is y equals to a sine bx, sorry. And what would be the period? This is the period. This period is 2 pi by b. And what is the amplitude? This is the amplitude, a. I hope I'm clear. What is period here, what is amplitude here, and how to graph this function. Now let's take an example to have the better understanding. So this is the example. Here we need to determine the amplitude for the given function, and we have to graph it for the interval 0 to 2 pi. Okay, so amplitude is pretty simple. Amplitude would be 3 here, right? This represents the amplitude. Now what is the period here? So period is 2 pi by b. This is the period. So 2 pi, here b is 2 here, so divide by 2. That would cancel, you'll get pi. So period is pi, right? Now let's find the 4 key points: x1, then x2, x3, x4 and x5. Now how to find these key points? x1 is 0 here. We'll start from 0, and now the second key point would be, now divide the period by 4, so that is pi by 4. Now add pi by 4 to it, so you'll get pi by 4. Again add pi by 4, you'll get pi by 2. Again add pi by 4, you'll get 3 pi by 4, and again add pi by 4, you'll get pi. These are the key points. Now corresponding to these values, find y1, y2, y3, y4 and y5. So y1, When x is 0, sine 2 times 0 is sine 0, so y would also be 0. Y2. When x is pi by 4, so y is 3 sine 2 times pi by 4 is pi by 2, and sine pi by 2 is 1. So this would be 3 here. Then sine pi by 2. Sorry, 2 times pi by 2 would be sine pi is 0, so you'll get 0 again. Then you'll get minus 3 and then 0. Now if you plot all these points on the graph paper, so this is the y-axis, right, and this is the x-axis. Now here this is 1 2 3, then 1 2 3, and here this is pi by 4, this is 0 here, then pi by 2, then 3 pi by 2, and finally 3 pi by 4, and finally pi, right? Now let's plot the points. So this is the first point. Second key point is pi by 4 3, so pi by 4 3 is here. Then pi by 2 0, this would be here, then this would be here, and finally here. Join this curve, these points with a smooth curve like this. This will go, then this, and then this, and like that. Perfect. So this would be the curve, but one more thing, we have to sketch it for 0 to 2 pi. We have just drawn for 0 to pi, because we know that the curve will going to repeat itself. So if I extend this line here like this, now this would be the next point. Add pi by 4 to it, so it will go up to 2 pi, right? So this point would be 2 pi. Now you can repeat this curve, so it will go to the maximum point and then back to 0, and then again the negative minimum point, and then here. So this curve is just a repetition of this previous curve. So this is the curve that represents y equals to 3 sine x between the interval 0 to 2 pi. Now let's move forward. Now before moving forward, I'm giving one homework to you. You have to sketch the curve y equals to 2 sine 1 over 2x. Sketch by using the same method, and then verify your answer by using desmos.com. It's a free website where you can sketch any type of trigonometric graph. So first draw on your own and then verify by using this website. Now let's move forward. Now we have one more variation for y equals to sine x. In the variation we have y equals to a sine bx minus c. This is the variation. Now here what would be the period? So we know that for y equals to a sine bx, here we have written that bx is greater than or equals to 0, less than or equals to 2 pi. So similarly here we can write that bx minus c is greater than or equals to 0, less than or equals to 2 pi. Now do one thing, add c to both the side. So 0 plus c is c, and here this would become bx, then less than or equals to c plus 2 pi. Now divide with b. So c by b is less than or equals to b, sorry, x here we have divided with b, then less than or equals to c by b plus 2 pi over b, right? Now here what this c by b, this is what this is showing. This is showing the x coordinate of the left side where the cycle will going to begin, and here this is also the x coordinate, but on the right side where the cycle will going to end. Okay, Now the graph of y equals to a sine bx, where b is greater than 0, is obtained by horizontally shifting the graph for this. And how much is the horizontal shift? Horizontal shift is from x equals to 0 to x equals to c over b. And what would be the period? Period would be 2 pi over b. If I conclude all those things, here you can see that here the shift, this is the horizontal shift. So what is the horizontal shift? From x equals to 0 to here, this distance is what? C by b. And the period is 2 pi by b, and this point is c by b plus 2 pi by b. This is the x coordinate, and here the x coordinate is c by b. Correct? Amplitude still remains the same. Mode A is amplitude. Now from these observation we can conclude few things. If c by b, if this ratio is greater than 0, then we have to, the shift is towards the right side. And if c by b, if this is less than 0, then the shift is towards the left side. These are the few points that you should remember. Now let's take one example so that you have better understanding. Now here we have to sketch this function y equals to 4 sine 2x minus 2 pi by 3 for one period of the function. Okay. So first of all, I'm going to write the amplitude. Amplitude would be 4 here, right? Then period is 2 pi by b. Now if you compare it with the standard function y equals to a sine bx minus c, here the period is 2 pi by b, so 2 pi, b here is 2, so that would be pi, so pi would be the period. Now the graph will start from x1, and this we have obtained earlier, that this x1 would be c over b. C here is 2 pi by 3. Correct? If you compare, c is 2 pi by 3, divide by b. B is 2. So that would be pi by 3. Therefore, there is a phase shift of pi by 3. So x1, we have to start the graph from pi by 3. Now we have to add what you have to add. Divide the period by 4. This is the method we always used, pi by 4. So x2, this would be pi by 3 plus pi by 4. So that would be 7 pi by 4. Sorry, 7 pi by 12. Now x3, again add pi by 3 to it. So 7 pi by 12, add pi by 3 to it. What you will get? You will get 10 pi by 12, which is 5 pi by 6. Then x4, again add pi by 4 here. You will get to be equals to 13 pi by 12. And finally you will get x5 to be equals to 4 pi by 3. Now many students have confusion that have we these key points are correct or wrong. Just do one thing, take the difference between x5 and x1. So that is 4 pi by 3 minus pi by 3. So that is 3 pi by 3, which is pi. This 3 and 3 will cancel, so that would be equals to pi. Here period is pi and the difference is also pi. That means the key points are absolutely correct. Now we can sketch the graph. So graph will start from this point, pi by 3, and it will end at 4 pi by 3. And what are the corresponding y values? y1, this would be, if you put x as pi by 3 here, so what you'll get? You'll get this value to be equals to 0, and here you'll get y2 to be equals to 4. Then here this would be 0, then again minus 4, minimum value, and finally again 0. This is y5, y4. Now let us sketch. So if you sketch, the graph would be something like that. This would be the graph. Here you can see that there is a phase shift of pi by 3, correct? And this is the amplitude 4. This is the amplitude 4, and this is the maximum point, this is the minimum point, and these are the 3x intercept. And this is the graph for the one cycle. This will going to repeat. Okay, so this is the required result and the required graph. I hope you got this. And with this we're going to end this video, and in the next video we'll see the graph for cosine x, and then also we'll see the applications of these trigonometric graph. So this is all for this video, and I'll catch you in the next video. Till then, take care of yourself and goodbye. Thank you.